Morning. How are you?
Good afternoon, everyone.
Okay.
Okay, welcome for all participants in the room D2S2 for remote sensing for city management and related topics. And for today's session, Professor Dr. Bangun Mulyo Sukoyo will be chair. Okay, all presenter already in the room?
Okay, thank you very much.
Okay, Professor, time is yours.
Okay, thank you very much. Ladies and gentlemen, good morning. And the season season primarily for you have the table, you have the excuse me, you have the table, the schedule.
Oh, for schedule,
Yeah.
Okay. Let me share screen for you,
Yeah.
Professor.
Yeah, okay. Thank you very much.
For the first presenter will be about multi-scale segmentation framework for unconflict building, and the second one is mapping and monitoring urban areas. This is the one. And the last presenter will be utilization of remote sensing in supporting rural mobility-based micro watershed management.
Okay, thank you very much. Yeah.
You're welcome.
Well, first topic is presented by Mr. or Mrs. The name Mr. or Mrs. For first topic.
Yeah, it's
Mr.
Mr. Muda Inward.
Excuse me. Yeah, excuse me, because I confused. Yeah. Okay, thank you very much for your. Yeah. Okay, because okay, thank you. You have the 15 minutes, yeah, for presentation, and then we will discuss your topic. It's time for you.
Okay. Good afternoon, everyone.
Good afternoon.
Let me quickly share my screen.
Yeah.
Can you see my screen?
Okay, it's ready.
Yeah. Okay. And can you hear my voice clearly?
Yeah. It's
Okay.
good.
Thank you very much. I would like to present our work titled A Multiscale Segmentation Framework for Uncompleted Building Footprint Extraction for Remote Sensing Imagery. These are the contents of the slide. Okay, I will start with the introduction.
Excuse me. Excuse me. You can present it. You come from your institution or some. Kita minute.
Oh, okay.
Okay. Yeah.
My name is Info Mahmuda Bello. I am from Northwestern Polytechnical University in Shanxi Province, China.
Yeah. Okay.
Okay. The introduction.
Yeah.
Building footprint extraction plays an essential role in remote sensing applications such as disaster management, geospatial analysis, regional planning, population growth, etc. The convolutional neural networks, also known as the CNN, Their automatic feature extraction capability makes them suitable for remote sensing application. Their performance supersedes most of the conventional method for segmentation. Several CNN-based methods have been proposed in the literature for building extraction, most of which are based on the encoder decoder structure. However, the major challenge is that most of the proposed approach cannot efficiently extract high-level salient features from remote sensing image. What I would like to say is it depends on how the features of the imagery is. Most of the proposed network can work better on images that have more features. For example, the image on the extreme left is a picture of a car and a building, which have more features to represent the particular object. Most of the network are mostly built based on this image. As you go further in the with image, you can see that the future representation of the object is not as much as that of the first image. So that will make the learning process challenging. And if you try to look at the image in the far right, you can see is a remote sensing image with very few or very few feature representation to represent the particular object in the image. For example, this is a building and these are cars. So for a network to learn these basic features and delineate between the objects, for example, the road, the car, is a very challenging task. So that is what motivates us to develop a new method. These are some of the existing networks, which are in most cases built based on the ground-based images. We have the FCN, the SegNet, and the unit. We categorize these under the single scale because the way they learn from the input to the output, they have unique spatial filters. Yeah, we can see some of the multi-scale approach like the GitLab and PSP. We use the AGERS convolution. The benefit of this type of convolution is that it enlarges the kernel field of view, incorporates large content without increasing the number of parameters. So in this type of network, a kind of checkerboard or a kind of dilation is being introduced into the network in order to recover the spatial dimension of the extracted feature. So let's try to look at the architecture of our proposed network. The network consists of 3 blocks called the subnets. Each subnet branch consists of a stack of convolution kernel of unique spatial size, followed by a corresponding feature map transformation layer. It consists of 3 subnets. One is called the step down, one is the pass subnet, and then the last one is the step up subnet. The step down subnet performs the feature extraction and the downscaling process using 3 types of filters or kernels arranged in multi-scale fashion, inspired by the inception model, as you can see it in the far right. The pass subnet also consists of the same 3 types of filters, and it constitutes the network's bottleneck. The step up subnet, the last subnet, which is the last type of the subnet, does precisely the reverse operation of the step down subnet to recover the feature map spatial resolution. The bilinear interpolation was used in these subnets to upscale the feature vector to twice its original size at each level to reconstruct the output segmentation map. We consider widening the network structure to capture the hierarchical multi-scale feature while maintaining the accuracy with minimum depth and parameters. This is the network structure. As you can see, the step down subnets, and then the pass subnet at the middle. Then we have the step up subnet. As you can see, it's not like the single scale, which have a unique filters for feature learning. Here we are using 3 filters to learn the semantic features. We have the 1x1, we have the 3x3 type of filters, and then we have the 5x5 type spatial filter. These three filters learn features at different scale, while all the feature maps are being fused or concatenated at each of the subnets before passing it to the next subnet for further feature learning. At the first input, we have the 7x7 large filter, and then followed by the subnet blocks, as can be seen in the picture. In the first step down subnet, we use the filters followed by pooling layers in each of the parallel combination of the filters. We use subnets, a pooling layer at the end to downscale the feature map, feature representation, or the feature map in order to reduce the network parameters. The pass subnet doesn't have the feature transformation layer, the pooling or the upsampling layer, because it is just used as the bottleneck, or the just for the bottleneck of the network. The step up subnets constitute of the same type of filter, but this time around it has the upsampling filter. We use the bilinear bilinear interpolation to upscale the feature map back to its original spatial size. So we use a data set, a custom data set, in order to train our network. The reason why is because most of the data set available doesn't have the capability to, or doesn't have the category of a particular building. In most cases, you find out that they categorize the data set into either buildings, roads, rivers, and etc. But in the buildings, there is no any data sets as far as our knowledge is concerned. We did not come across any data set that has the category of buildings and the rest. So our major target is to extract and segment not only the building footprints, but the category of the building from the satellite imagery. Here we try to extract the uncompleted buildings from a particular satellite image. And uncompleted buildings are structures raised but not reaching completion, which pose a lot of security challenge in the sub-Saharan Africa region. So we use a 0.6 meter resolution satellite imagery to generate our custom data set. We create 4 image tiles with a total land cover area of 26 square kilometers to generate our training and validation samples. We divided and manually annotated the dataset into training and validation tiles. As you can see the tiles. We have 4 tiles. We generate the 4 tiles out of the data sets. Out of the 4, we keep the 3 tiles for the training, and then the last one for our validation. As you can see in the image inset, you can see a yellow, the yellow part of the inset is the completed building, while the black part is a pictorial view of the uncompleted building, which is our target. So we train the network alongside all other multi-scale segmentation framework. We use the cross-entropy loss function and the stochastic gradient descent for optimization to train the network. The prediction result was compared with that of the DSM net unit and the deep lab. The DSM net being and the deep lab being a multi-scale segmentation, while the unit is a single scale. As you can see, the learning curve clearly indicates the performance of the network. So this is the performance on the validation data sets. We use the mean accuracy as well as the frequency weighted intersection over union as our metrics. And then we also examine the parameters as well as the flops of the network. And then also we try to track the training time of each of the network. As you can see, well, the accuracy of all the networks are not very far from each other. But as you can see, the parameters of ours is a bit more efficient than that of the remaining networks, and the training time also. So we perform.
Mr. Mahmuda.
Yeah.
Your time 5 minutes.
Okay.
Okay.
We perform an ablation study in order to ascertain the performance of the network. Here, since we are using a multi-scale network with different filters, we try to add more filters to see what will be the response of the proposed network. As you can see, the first column, we use only 3 and 5. We get the accuracy as well as the training time. We use the 1 and 3. We use 1 and 5. And then all the filters, as you can see, we track all the performance. So the more you add filters, the accuracy will improve, but at the expense of the network parameters and the training time. So this is the model evaluation. As you can see in the left-hand side, we have the ground truth and the prediction. And then here we have some samples which shows how the network, a close look at the samples of how the network trained. We use the georeferencing format in order to map the predictions with the corresponding ground truth. And then this is a close look of the predicted samples of the buildings with all other graphs being suppressed. As you can see, the performance, though it is not very accurate, but at least you can see the the difference between the completed and the uncompleted, while the uncompleted is the only one being extracted from this. And this on the right hand side, you can see the geographical distribution of the classified uncompleted building structure, which shows the distribution of the uncompleted building structure within the study area. In this article, a lightweight multi-scale segmentation framework for building extraction was proposed. The model was deployed on a challenging low-resolution satellite images to segment building and segregate between the building's semantic attributes. So we also propose an efficient and highly accurate approach to deduce uncompleted building structure with their corresponding geographical location. The experimental results present have verified that our proposed network have a great potential in remote sensing building extraction. So thank you very much for listening.
Okay, thank you very much, Mr. Mahmuda, for your presentation. Topic is very interesting. With the CNN, you can utilize with the remote sensing for building, and then for continue the program discuss for your topic.
Yeah, thank you very much.
You have any question? I think it's a very, very important the topic, for BIM. I think you know BIM, building information modeling. question? Do you have the question for Mr. Mahmuda? No? Any question? I pose question for you, Mr. Mahmuda. What's the correlation with the BIM?
Between
BIM, building information modeling, your topic.
what is the correlation?
Yeah.
Between building?
The advantage for BIM, for example.
Sorry, I didn't get it correct.
Yeah. What's the advantage? Your topic in BIM, building information modeling.
Oh, building information modeling.
Yeah.
Oh, okay. Well, I can say, as you can see, if I understand your question clearly,
Yeah.
the application of building, as I said in this slide, the application of building extraction in the remote sensing.
Yeah.
It can be used for disaster assessment.
Yeah.
It can be used for geospatial analysis, and then regional planning and population growth estimation. For this, I can say this work is more of a regional planning or a governmental decision process of a certain region. Yeah. That is where the application comes.
Yeah, it's especially for level 1 for building information modeling. You know, the in BIM we have the certain level, yeah, level 1, 2, 3. In the region planning, I think it's the level 1. Is right?
Yeah. Well,
I
don't know that.
Yeah. Okay. Thank you very much.
Thank you very much. Thank you very much for listening.
I think the topic is very important and interesting for continuous. Good luck.
Thank you very much.
Okay, and we continue the second topic with the Dr. Muhammad Iqbal Habibi. Yeah, with the topic mapping and monitoring urban area using Sentinel-1 and Sentinel-2. Yeah, time for you, Dr. Muhammad Iqbal Habibi, please. Excuse me, Mr. Mahmuda, you stop clear. Okay.
May I share screen?
Yeah, please. You can stop the screen, Mr. Mahmuda. Okay. Now, time for Dr. Muhammad Iqbal. Please. Okay. I think you presented your institution and your job, etc. Thank you very much.
Okay, the presentation is shown.
Okay, it's okay. Yeah.
First, thank you for Dr. Bangun Mulyo Sukojo as the chair in the sessions. Good afternoon, ladies and gentlemen. Thank you for your coming. It's an honor to me to attend this wonderful conference for the 2020 and 21 IEEE Asia Pacific Conference on Geoscience, Electronics, and Remote Sensing Technology. My name is Muhammad Lutfi Aziz as the presenter in this session. I work in the National Research and Innovation Agency, Republik Indonesia, previously known as Agency for the Assessment and Application for Technology. The authors in this research is the first The first author is Dr. Muhammad Iqbar, then Muhammad Dayuf, Miss Nunggraheni, Mr. Teguh, and Mr. Nurdiansyah, and me. Actually, Mr. Dr. Muhammad Iqbal is the lead the lead author and the presenter today. But because he is the moderator in room 3, so I was asked by him to replace him to be presenter today. Okay, today I would like to share my presentations about with the title the mapping and monitoring urban areas using Sentinel-1 and Sentinel-2. Okay.
Excuse me, Mr. Muhammad. Your time 5 minutes, yeah. 5-10 minutes. 5-10 minutes, yeah.
Yeah. The outline of presentations is first introductions to the area, data, methodology, result and discussions, and conclusions. For the introductions, climate is one of the most important environmental elements affecting not only our ecosystem but also our daily life. Urban expansion has been a major concern in land cover change, which has result in the deteriorations of vegetation and environment. Multi-temporal Sentinel-2 data and synthetic aperture radar or SAR Sentinel-1 data are frequently utilized to generate urban sprawl index. The normalized difference build-up index or NDVI and normalized difference vegetation index or NDVI, both measure of an urban head island effects, the effective for detecting the change in the metropolitan environment. The study area in Bandar Lampung. Bandar Lampung is also the biggest and the second most populated city on the Sumatra Island, with population density 5,333 kilometer acre. Geographically, the city is primarily a trans to Sumatra Islands, about 165 kilometers northwest of Jakarta, and plays a significant role in the island's transportation and logistic distributions operations from Java to Sumatra and vice versa. In 2019, most countries saw higher growth rate than in prior years. In the 2019, the industry sector with the highest growth rate in accommodations and food services. Bandar Lampung has total land area 169 kilometer acre, is split into 20 sub-districts, and has a population 1,166,000 people, in the figure 1. This is the graphic average temperature and precipitations in Bandar Lampung. The city's climate is typically tropically, with hot and humid weather all years, and the temperature is consistent. The graph illustrates that this considerable rain occurs throughout the first 3 months, and years, with the greatest mean for the daily maximum temperature occurring between October and September. This research methods use Sentinel-1, Sentinel-2, and Sentinel-Hub. ESA, Snap Desktop, and QGIS were used for all image processing and analysis for processing. But we use EO browser tools to visualize the result instantly with the algorithm. The dataset information, we use datasets on 10th December 2019 using Sentinel-1 and Sentinel-2. Sentinel-1 data is provided by 2 polar orbiting satellites that operate day and night and use C-band synthetic aperture radar. The main use are for monitoring sea ice, oil spills, maritime winds, waves, current, land use change, land deformations, and responding crises such as floods, earthquakes, amongst others. The spatial resolutions varies depending on mode about 5 times 20 meters for IW mode, and approximately 20 times 40 meter for EW mode. IW. Okay. Next, then we use data Sentinel-2 data. Sentinel-2 is multispectral imager with 290 kilometers watt dedicated to providing data for Copernicus services. Then we use Sentinel Hub. Sentinel Hub provides an easy-to-use and cost-effective way to exploit the data in AGERS applications or integrate it into web applications by utilizing advanced Amazon Web Services, cloud technology, and innovative methods of efficiently processing and distributing data. Sentinel Hub remove the significant burden of downloading, archiving, and analyzing petabytes of data by simply making the whole global archive available via web services. This is the example Bandar Lampung city map using Sentinel Hub. This is the web. Picture of the web. Next. Methodology. In this part, we will visualize the mapping build-up areas using NDVI and NDBI, and the identifications of the urban area using a Sentinel Hub. The first is NDVI mapping build-up areas. NDVI is an index that describes the greenness of the plant. The vegetation index is mathematical combinations between the red band and the near-infrared radiation band, which has long been used as the indicator of presence and conditions of vegetation. The initial stage was to detect clouds and cloud shadow. This step is critical since clouds might influence NDVI sensors. The cloud mask created by ESA was used to remove clouds from image from this purpose. This is the formula of NDVI. You can show it. You can see it. And the second is NDVI mapping build-up area. NDVI, which is also called normalized difference build-up index, and you can say it UI or urban index, is an index that is very sensitive to build-up land or open land, which is developed to highlight the appearance of build-up lands compared to other objects. The normal NDVI identifies cities with greater reflectance in shortwave infrared spectral region. Then the identification of urban area using Sentinel Hub. The Sentinel Hub can use the Sentinel Playground to allow a rapid online visualizations and access to Sentinel-1, Sentinel-2, Landsat 8, DEM, and MODIS image as explored the world. We developed the algorithm to identify urban areas using Sentinel-1 using the formula expressed below. We take from Monja Sabella. Then from the Sentinel-1, to generate the identifications of urban areas, we propose the algorithm, the combinations of Sentinel-1 and Sentinel-2 as below, like equal 4. You can see this like this algorithm. We combine for combine Sentinel-1 and Sentinel-2. And the result in this the results show that all estimates indicate in this may be useful for detecting urban areas. In this picture above, it can be seen the light green pixel on NDVI and the red orange on NDBI using Sentinel-2 imagery are built up areas. You can see it. Is next. Then in the figure 5, shows a mapping of urban areas using Sentinel-1 image that was processed using a Sentinel hub. In the picture, the green pixel show the build-up area. You can see this like the green pixel is the build-up area. Then in the figure 6 is the fusions image of Sentinel-1 and Sentinel-2 data using the algorithm described previously, from the result of the fusions of two data, Sentinel-1 and Sentinel-2. It can be seen that the green pixel is the build-up area. You can see the green pixel is the build-up area. Okay. Then the conclusions. Actually, this research still in primary study, maybe like preliminary study. This research was improved to distinctions between build-up and unbuilt-up areas by analyzing Sentinel-1 and Sentinel-2 data. The research were developed in DVI and NDBI to see the urban areas. The research also developed the algorithm use of Sentinel-1. Sentinel-2 will show that the NDVI mapping show better than NDBI result. However, the greatest one attained for the urban mapping using Sentinel-1. That's all from me. Thank you. I give to Mr. Dr. Bagus Sukojo.
Thank you very much for Mr. Muhammad Aziz. Yeah, this topic is very important, very interesting for urban area, I think. I think for this discussion, the topic, maybe any question for Mr. Aziz, please.
Yes, sir.
Yeah. Yes, please.
Thank you, Mr. Chairman. My name is Sumargana.
Yeah. Yeah. Okay.
Thank you, Mr.
From Mr.
Yes.
Sumargana from
from BRIN National.
Okay. Yeah. Thank you very much.
Nice presentation, Mr. Lutfi Aziz. But I need to clarify. In introduction, you mentioned about the weather, like heat and other. So, is there any correlation with this information to your data for Sentinel-1 or Sentinel-2? Thank you.
Okay.
Okay. Yeah.
May I answer this question?
Yeah, please.
I'll try to answer. Actually, the lead author is Mr. Muhammad Iqbal Habibi, but I will try to answer the question.
Yeah.
The temperature and precipitation graphic is show about can show to the Sentinel data as the I'm sorry, the temperature and precipitation is a correlation with populations of people. So when the temperature is high, it positive correlations to population of people. So when you use NDVI, it will be it more be see from the image. Do you understand what I mean?
Okay, thank you. But I think it's your application or your methodology is suitable for the urban area in the city or something like that, where there are electricity or network of electricity. It is possible to apply in the area where the suburban where there are no electricity. Thank you.
Okay, thank you very much, Mr. Sumardana. I think my suggest for you, Mr. Lutfi Aziz, yeah, maybe you can make the metric correlation metric, yeah, between certain parameter for presented parameter in your topic. I think, for example, for temperature and precipitation, and then in another parameter.
Maybe
Yeah.
for the next research, we will use a temperature to complete the research.
Okay. 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 Yeah. Any question? Another question for Mr. Muhammad Lutfi. Okay, it's enough. Thank you very much, Mr. Muhammad Lutfi, for your topic, mapping and monitoring urban area using Sentinel-1 and Sentinel-2. I think for future research, yeah, or publication, I think with the comparison with the another satellite, yeah. Okay, thank you very much. Applause for Mr. Muhammad Lutfi, please. Okay, your yeah, your the screen. Okay, thank you very much. And then we will continue with the another topic with the Mr. Budi Heru Santosa, yeah, Mr. Budi Heru Santosa with topic utilization of remote sensing and supporting rural community-based micro watershed management. Okay, time for you, Mr. Budi, please. Hello, Mr. Budi. Mr. Budi or another author, I think. Mr. Budi or I don't know.
Could be Mr. Awal, Pak.
Mr. Awal. Okay, thank you very much, Mr. Awal. Yeah, you presented your topic. You have the time is 15 minutes. Yeah, thank you. Mr. Awal. Yeah. Mr. Awal Subandar. You are ready? Mr. Brian. Another person who presented. Mr. Awal, not present. Mrs. Mary Efriana. Mr. Mary Efriana, you are present? Okay, another person. Mr. Nugroho, you're present. And then Mrs. Anissa, you're present? Not yet. Hello? Mr. Brian?
Oh yes, Professor.
Yeah. Because for topic last topic, utilization of remote sensing in supporting rural community-based micro watershed management. Yeah.
Mr. Awal is ready, sir.
Okay.
I'm.
Oh, Mr. Awal. Okay, thank you very much. Yeah.
Okay.
Okay.
Yeah.
Thank you, Mr. Chairman.
Yeah. You introduce, excuse me, Mr. Awal, you introduce your institution and I don't know, another your experience, yeah. Thank you very much.
Okay. Thank you for the occasion. Let me start with introducing myself. My name is Awal Subandar. I am the member of Center for Technology Development of Regional Resources of BPPT BRIN. And allow me to share my presentation, Mr. Chairman.
Okay, thank you.
Yeah.
Your time is 15 minutes, yeah.
Okay.
Thank you.
Actually, I speak on behalf of my colleagues. They are four writer of this article, and yes, basically the idea is we want to propose the approach in integrated watershed management.
Okay.
Because there are many approach, and our approach is based on Indonesia. We call it kawasan pedesaan. Yeah. Because that's what is that? The soul of undang-undang desa or village law.
Okay. Yeah.
So we would like to propose that idea that because if we implement the rural area empowerment in watershed management, we execute two things at the same time, simultaneously. Okay. We develop or protect the area, the territory, because the watershed, the micro watershed that we are going to manage is part of the rural area. And secondly, as the physics or the territory, the human resources in that territory will be developed as well. So we have to development at the same time. And I think it has been proven at many places, such as India and other places, that when we manage watershed, it's not merely the physical, the land or the erosion process, but also we have to consider the social economic of the area.
Yeah,
that's the basic idea. And I think we have problem with presenting the, what is that? The presentation. Sorry, Mr. Chairman, is a bit late, but I can make it short at the back.
Okay. You have not the PPT, Mr. Awal?
Yes.
You have not the PPT?
Yes, PPT.
Oh, yeah. Okay, yeah. Thank you.
I think just to emphasize, as has been found in many places, as I said before, and like in India, considering social economic aspect is also important in water resource management, watershed management. And now, if we develop based on watersheds, that's too large. The area is too large. Like it could be covering different or many jurisdictions. For example, in the case of Citarum, it covers so many kabupatens and kota. Although in the same province of West Java, but still it passed several kabupaten and kota. So the idea in many places, like in Indonesia, we also adopt the idea by using we call it micro DAS, micro watershed. Basically, the watersheds is divided into many sub watershed, and then if it is still large, then we divide again the division until the smaller unit we call it micro watershed. In Indonesia, we only adopt the approach as MDM, model das micro, model of micro das, micro watershed. So the approach is, in case of micro watersheds, is already quite popular in Indonesia. But if we combine with rural area development, the approach of kawasan pedesaan, I think it will be more powerful.
Yeah.
Because we found there are, in my presentation, I will emphasize there are 7 tools at least, 7 potential tools that can be capitalized to improve watershed management. For sure, remote sensing and GIS is an important part of that, but also there are some other tools that we can capitalize from rural area empowerment or pemberdayaan kawasan pedesaan, and that's the basic idea of our presentation. I don't know what it's so slow. Yeah. Okay. No.
Lagi kirim ke Brian.
Okay. Mr. Chairman, we have to pass the presentation to Mr. Brian Sencaki because I have problem with my network here. I think Brian can take over the. It's a small presentation. It's only 2 megabytes, I think. We already sent it. Brian, can you take over?
Yes, it's still downloading.
Okay.
I will share screen for Mr. Awal for presentation.
Okay.
Okay. Just a few minutes.
Okay. Sorry for this trouble.
The presentation is ready.
Okay.
Should I share screen right now?
Yes, please.
Sure. Okay.
Okay. Thank you.
You're welcome. Okay, share screen. Yep.
Okay.
Okay.
Okay. Next slide, please. Okay. As I mentioned earlier, the objective of this paper is we are going to propose potential utilization of remote sensing and GIS, that's for sure. But we are going to emphasize the use of remote sensing and GIS with a new approach in watershed management, is by implementing pemberdayaan kawasan pedesaan, rural area empowerment. Okay, that's we can have great glimpse idea of the paper. Next slide, please. Can we? Yeah. Okay. Basically, in Indonesia, we have that quite big number of river basin, and less than 10%. That's about 7 or 7 to 8% of the total area is in poor condition. You see, but it is still a big work, a delicate work program to rehabilitate the watershed in Indonesia. And if we learn from history, there are many approaches in managing river basin or watersheds. It can start with the concept of one river, one management plan. That's back many decades before, like 1930. And then we see that government play central role in river management, in river basin management. And then following the year, their concept of sustainability and so on, and public wants to share their work in river basin management, in managing natural resources. So that's come an idea to develop. If before is government, central government is the central player, then they start to share the public, local community. Then they develop the approach of community-based management. It's going on, and back to the 1980, India and some other countries like Indonesia as well, actually, we found that concentrating on technical aspect is not the only answer to river basin management. We have to also incorporate, we have to also consider the social economy of rural people, the issue of rural area. So that's after a decade or so, India and other places, and eventually Indonesia as well, consider the approach as to be implemented as well. Okay, next slide, please. I think just make it short. So collaboration of stakeholders, we have to involve academia, business, and also the media in watershed management to raise the awareness of public in watershed management. I think that's like a good example in our what is that? I mean, in Indonesia, we have the problem of Citarum River. Now, even the president take this as a priority, and in seven years, Citarum River must be back to an ideal condition. So the government move or try and exercise with military stakeholders as the front runner of this program, and followed by local people. So that's why in this case, why not we also move forward the development or the empowerment of rural area. We are going to see the next slide, please. Next slide, please. I think the data and method we emphasize on literature review and study comparison with other region, and basically the tools using remote sensing and GIS. And next slide, please. Yeah. I'm not going to elaborate what is watershed management. Basically, is how we interact with the nature to make the nature can sustain forever, and we as human being can take advantage of the existence of natural resources. That's the basic idea of watershed management. And I mentioned before, if we consider watershed as one unit, and that's too large to be handled, because it may cover so many jurisdictions. Like Citarum, it covers like several kabupatens, and usually every kabupaten or every regency has a policy that might be different with the neighbors. So that's why that's the problem if we use the one watershed as one unit of planning. So that's like, as I mentioned before, in other part of the world as well, experts suggest to divide the watershed into smaller unit, and finally they found that micro watershed is the smaller and viable unit to manage. So we can use this. You can use this as a planning unit in preparing development program of the watershed management. That's the finding. Okay, next slide, please. Yeah, next slide, please, Brian. Okay, people are dealing with remote sensing and GIS should already know that. Then this is the approach. Experts provide data and delivered it, the information, the spatial-based information into rural community. And we need assistance from facilitator, we call it. Because at the next slide, we are going to see that how we can use this information for the rural community in managing micro watersheds. Next slide, please. Yeah, this is some legal aspect of rural area development, because in rural area development, there are at least 11 sectors that would be developed simultaneously, starting from basic needs, food, housing, clothing, and so on, until education, health, and infrastructure. So if we follow this, the development of rural area as well as the people, the community live in the rural area will be developed simultaneously. This is just the legal aspect. I think participants could review later. Next slide, please. Yeah, if we compare between WRM is watersheds resource management. Jadi WRM stands for watersheds resource management. If we compare with rural areas development, at least according to us, there are 7 tools that we can capitalize to do so. Okay, number 1. The next slide would be the same thing, but in different slide. 1, the size of macro watersheds would be equal to the number of the area of rural areas, because rural areas basically consist of several villages in the same kabupaten, in the same regency. And based on the experience in India, and I think in several parts of Indonesia, like in South Sulawesi and in Lampung, the size of micro watersheds is equal to the size of rural areas, because rural areas consist of several villages. Okay. Secondly, if the area is about equal, and all the villages in the same microshed, that will cooperate in managing the natural resources. In this case, is the watershed. In cooperating, they have to refer to the same. We call it RPKP. What it stands for? Rencana Pembangunan Kawasan Pedesaan. See the development plan of rural areas empowerment. In that document, the RPKP, all the 11 sectors of development of rural areas must be elaborated in detail. So any purpose aligned with watershed management can be adopted to the document. That's the second thing. I think Wijan, you better move to the next slide. It's easier to read than this one. Next, please. Find the 7 tools. I already this is the example from microshed division at North Bandung. This is part of the project Citarum. Now it's a national project. Next slide, please. I think the conclusion. Okay, so let me emphasize one more before I jump to the conclusion. So first, the size of micro watersheds is equal to a rural area, is equal to several villages located in the same regency. Secondly, the development in rural area is guided by a document called RPKP, Development Plan of Rural Area, which consider 11 sectors, and that will provide opportunity for the people, the local people, the local community to put some consideration what they need to develop their area, to develop themselves as well, and to develop the watershed. Because basically, as I mentioned before, it consists of several villages in the same microshed. Okay, and another thing is every village enjoy what we call it dana desa, a village fund. Now it's up to 1 billion rupiah, close to that number per village. So if several village join in a rural area, you can imagine there will be several million rupiahs that can be utilized to develop watershed. And in practice, this funding could be used as a complement of expenses that cannot be covered by other party. For example, line ministry or technical ministry usually can provide seed plan for replanting the watershed. For example, the Ministry of Forestry and Environment, they have budget, they have what is that? The activity of a plan, seed plan, but they don't have expenses for transportation of the seed. They don't have expenses for maintaining the seed to grow, maintenance expenses they don't have. So no transportation cost, no maintenance cost. So basically they just provide the seed plan, allow the village people to plant it at the marginal land, but they don't have maintenance expenses. In that case, the village fund, the Dana Desa, can be utilized to complement for transporting the seed or to maintain the seed to grow and become a solid tree to support rehabilitation of the marginal land. So in doing so, I think the rural area development can provide development of the territory, several villages, which is equal to the watershed, micro watershed, and at the same time as well, the local people, through the work of maintaining the seed that plant through the program of Padat Karya, we call it labor intensive. So at the same time, the village fund go back to the local people, can improve their economy and increase the possibility of make it the replanting become a good work to provide protection to the marginal land. So I think at the end, there is a big possibility that watershed can be maintained to be in a shape that we aim at the start. So at the end, needless to say that we have some examples that remote sensing and GIS provide essential tools for supporting the work that I have been mentioned before. So in short, finally, I can say that rural area empowerment is very potential to be implemented in Indonesia in rehabilitating the marginal land, which now is about less than 10% of the total watershed area throughout the country. I think that I can deliver, Mr. Chairman. Thank you for the opportunity.
Okay, thank you very much, Mr. Awal. This topic is very important and very interesting. It's not a technical aspect, but it's the conceptual aspect or management correlation between remote sensing and GIS with the social and economic, especially for rural community or village, with micro literacy. It's very important for guiding the application of remote sensing and GIS in the rural area. Thank you very much, Mr. Awal. I continue with the. If you have the question for Mr. Awal, please. You have any question? Okay. You have any question? Because certain incident, I think if any person from the geographic or from the social economic, for example, please, you personal question. You have any question for Mr. Awal? Okay. Not yet. I think I have the question for Mr. Awal. Yeah, I pose question for you, Mr. Awal.
Yes.
In a law, rural or village, and the law have the system, information system. Yeah, it's not a mapping, but it's the information system. Yeah. What's the difference between the map or mapping in this law in information system or map in the system? Because I read it's not the map, but it's the information system. What's your opinion? Thank you very much, Mr. Awal.
Yes. Thank you, Mr. Chairman. I think let us don't intermix with the terminology. When you said village, I think we refer to the same. In Indonesia, we call it desa, right? Ya, Pak ya?
Yeah.
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 Okay. And then rural area, I translated as assemblage. Is a pool of villages that share the same, that share boundary and located at the same regency.
Yeah.
Okay. That's the idea. If in the past, usually the approach of rural area is used for, what is that? Developing their potential resources. If one village produce corn,
one product,
and others corn or rice or whatever, if they join, if they cooperate, and they will have a better bargaining position in developing their product. So there will be the stronger will diminish the weak one because they already cooperate. But if we talk about the future, I think people talk about how we use the cooperation to solve the mutual problem. Because if we, as I found the case in some regions in Sumatra, the head of the village, if explaining like socio-economic development, they are going to build pusat jajanan, whatever. with the village fund, they can speak it up easily.
Yeah.
But at the end, they complain that they have problem with flood.
Yeah.
And when I asked, the floods just exist in your village or it comes from the next village? Eventually, he acknowledged that the upstream, the village at the upstream of the river usually send the flood. So that's why I proposed to him that why don't you cooperate with the upstream villages to handle this flood. So that's the basic idea. I think based on the finding, I believe the concept of rural area is not yet popular among the local. Among the people in the village. Because so far they just mainly focus on economic of using the village fund. Actually, they can use the approach of cooperating in handling mutual problem. I think that's the idea has to be spread out more and more. Not just like Pak Bangun lecturer at AGERS. I think academicians usually know about that. But I think in the future we have to develop to raise the awareness of people in the village that actually they can cooperate, handle their mutual problems, and this is the example to micro watershed management. Because in doing so, they will take care of the territory, the villages, and at the same time, through the RPKP, the Rencana Pembangunan Kawasan Pedesaan, we are going to develop at the same time 11 sectors that can improve the prosperity of local people. So this dual approach, physical or territorial development and people development at the same time, will be a good tools to combat illegal logging or erosion. And then I think we can develop good management practice in land cultivation and so on. So in the long run, I believe if we do so, we can do the micro watershed management to improve river basin as a whole. And I think finally I go to your question. Yes. Information system is, I think now is I think one of many things that they are going to develop in the villages. Because what do you call it? We sell products through internet. It's quite common now. So they are aim to. But they are trying to achieve as well in the village. Like people produce avocado. And then sell it to the consumer in different part of the country. For example, I can mention we call it pasir avocado produced in East Timor. There the price is only less than 10,000 per kilo. But the last consumer in Jakarta has to pay more, like more than 50,000 per kilo. The benefit of that price is enjoyed by the, what is that? We call it pedagang perantara. But now with this IT technology, with the advantage of Internet of Things.
Yeah.
Now,
IoT.
I think Kominfo, through their Yayasan Bakti, they have a program of broadband village. That will very close to your idea to have a information system. Part of the Internet of Things. So what is it? Trading through Internet is become more and more popular in the village. But if we talk about spatial mapping, information relating to spatial-based information, I think there is another step, and expert like Pak Bangun and so on in an university should provide your assistance to the village people. So at the same time, because we believe and agree that spatial technology is very powerful in natural resource management, right? So in doing so, I think what we propose through this article, I think expert academics in university and research agency like we in BPT and so on can provide assistance to the local community in improving marginal land in some watersheds throughout the country. I think what we see in like directly in front of us is Citarum, the case of Citarum. I think we have to support the government that in 7 years Citarum must have a good condition, like river that we see a clean one, a green surrounding area, because what we see now, very polluted water, garbage everywhere. That's through this idea, I think expert can provide spatial-based information. Villages have potential, and eventually they enjoy dana desa. Close to 1 billion rupiah per village. If they are like 10 village join a rural area, then would be 10 billion rupiah. That's very high funding that can be capitalized to develop the river basin management. So I think there is a big possibility for that one. Back again, information system now is being developed at the village level, but if we talk about the spatial-based information, they need our assistance. And I think the obligation of people like Pak Bangun, like my colleagues in BPT to provide that kind of assistance to make it happen in the future. I think that's my answer. Thank you.
Okay, thank you very much, Mr. Awal. Actually, in this room, I with my student in the class, and I think it's very important for there because in my student, we have the certain lectural, geography, development geographic, and then the programming for rural. The name now is the program in university is MBKM. MBKM is the Merdeka Belajar Kampus Merdeka. All the student is possibility for developing village or desa. With your program or your concept, I think it's very important for us, Mr. Awal. thank you very much for your listening. Yeah, for your concept. I think for future we can discuss and I think it's we can share what you do and what I do. I think it's very important for Indonesia for future. Thank you very much, Mr. Awal.
Okay, but I look forward to cooperate with your students to implement this approach in making a better condition of many of our watershed throughout the country. Thank you.
Okay. 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 I think it's I don't know, with your applause for Mr. Awal with your sign. Yeah. Thank you very much for this session, and then I come back to Mr. Committee, Mr. Brian. Thank you very much.
Thank you so much for your presentation, Mr. Awal Subandar, and let's conclude our session for today. Thank you again for all presenters for your insightful and compelling and even great presentation for Mr. Awal Subandar, Mr. Muhammad Lutfi Aziz, and Mr. Mahmuda Inuma. Thank you so much for the presentation, and especially thank you for Professor Bangun Mulyo Sukoyo for being chair for this session. Thank you so much. And before we leave our break room, we need to have our photo session. Could everyone please turn on your camera?
Yeah.
Okay. So we will have a photo session shortly. Could you please turn on your camera? Okay, we will have a 3-part of photo session because we have a 3 page. Okay, I will have photo session for 4th page. Okay. Okay, 1, 2, 3. Okay, for the 2nd page, 1, 2, 3. Okay, and for the 3rd page, 1, 2, 3. Okay, thank you again for all your participation.
Thank you.
Thank you so much, Professor Bangun Mulyo and everyone.
Yeah. Okay.
And,
thank you.
And please
permit the live room.
Yeah, please for you may return to your main room. You may return to the main room because we will have an announcement about who will be the winner for the best presenter and best paper. And yes, please return to
room. Who join in
main room.
Main room.
Yes.
Yeah. Okay. Thank you.
You're welcome, Professor. Okay, thank you, everyone. See you again at the main room.